So when we're talking about gradient, this is the first step. This question actually refers to gradient. What is gradient? Thinking about what we were doing yesterday. Yeah, it is the slope, okay? Or it measures the steepness of a line, okay, of a straight line. And if I wanted to work out the steepness of this line, okay, we kind of worked it out yesterday, but we need to pick, let's pick 2 points. So somebody tell me 2 points that they pick. Yes, Bella?
Where the line like stops the 3,000 0.
Here?
Yeah.
And what was the other one?
2755.
2755, which is here?
No, like 50. 2750 and then like 5. And then 5.
Oh,
2750,
sorry.
comma 5.
Okay, so you made a triangle out of these two. I'll try and do this as neat as possible, not like that. Let's use a straight line. Zavi, do you have it?
I think so.
Okay, and in order to work out the slope or the gradient, we need this distance. Now, what is this distance? 250. Now, we're moving in a downward direction, so it's actually negative 250, okay? And what is this distance?
5.
Yeah, 5, because we're going from 0 up to 5. So to work out the gradient, we were told that we had to do the difference in y, change in y, which in this case is negative 250, divided by the change in x, which is 5. And negative 250 divided by 5 is? Right, awesome, good. Now what do we notice about if we pick any 2 points on this line? Yeah, we're going to get the same answer. Now somebody explain to me why we get the same answer. Yes, Sienna.
Because the data is linear, so it decreases at the same rate.
Exactly, okay, and that's really important, okay? If we've got a linear equation, a linear curve here, or linear function, okay? So at any point on this line, it is always decreasing at the same rate, okay? So it doesn't matter if I look at this distance, so if I'm taking this triangle, which is 500, negative 500, it's going down over 10, okay, because it's always the same rate, I'm always going to get the same gradient, okay? It doesn't matter at which point, it's decreasing at the same rate each time. And that's kind of what we were looking to discover. Now, if I want to generalize this, now let's just go to a new page. And let's actually write this down, okay? The equation. Actually, the formula. So this is the title here. So the formula for finding.
Are we going to complete this sheet?
Yeah, shortly.
That's a long time. Is it going to take up like a lot of space, or should I just continue on the same page?
Yeah, you need more space. Alright, so we're looking at the formula for finding the gradient of a straight line. What I'm going to do is, I'm going to draw a sketch. Okay, I'm going to put on, let's say, 2 points. Let's imagine that this point is 1, 2. And I'm going to put another point on here, which let's call 7, 9. And I'm going to draw a straight line between them. Okay, so it's just a sketch. It doesn't need to be drawn to scale or anything like that. This is my x-axis, and this is my y-axis. So in the previous example, in order to work out the gradient, what did we have to do? Or what did we? Yeah, we drew a triangle, okay? And I can do exactly the same thing here. There is a formula, but see, what we're going to do is we're going to use this to come up with. We've got a triangle. And what does the triangle actually give us?
The distance between the y and the x. The distance that the y is from the x.
Right, it gives
And
us.
the distance that the x is.
It gives us this distance, and it gives us this distance, okay? Now, how do we go about getting this distance, say, using these 2 points? Have a think about it first. All right, so what do we think? How do we find this distance here in this triangle? What do you think, Christian?
y1 minus y2.
Okay, now where are you getting y1 and y2? I know what you're saying, and it's good, but looking at this specific example, what would you do?
Minus 2, which we're doing the y-axis.
Yeah, we're doing the y-axis here.
So 2, we do 9 minus 2.
Right,
so
okay.
y2 minus 2.
Good, you would do, so let me just write it in, 9 minus 2, and that would give me a distance of 7, okay? Because if we look at it, very good. My y coordinate here is 9. My y coordinate at this point is 2, okay? So the distance between those is 7, okay? So that's 9, and that's 2. So there's a distance of 7 between these. Does everybody kind of see that? Okay, so it's going to be 9, take away 2. So that's my rise part. And I have to divide that by the run part. Now doing the same type of thing. Can somebody tell me the 2 numbers I need to deal with there? Yes, Sam?
7 minus 1.
Right, okay, good. 7 minus 1. So my x coordinate is 7. My other x coordinate is 1. So that gives me a distance of 7 take away 1, which is 6. So that's my run part. So I've got 9 over 2, which is 7. 7 take away 1 is 6, which would be my gradient. 7 divided by 6. So we can put that in. And you can remember how to change this into a fraction on the calculator here. Yep, Sam?
Second, and then.
It's difficult to see, yeah.
And then it's F to D.
Yeah, F to D,
I
so
couldn't
it's,
see it.
yeah, it's difficult to see. And again, I'll put it back into 7 over 6. Now there's a way to, how do we change this into a mixed fraction on the calculator? It's this one here. I know it's difficult to see. You'll be able to see it easier on your computer at home. But you can see it goes from an improper fraction to a mixed. So I would do second and this one. And we get 1 and 1 sixth. Okay? So make sure you use your calculator and be able to do these things. We've got 1 and.
So on a test, would you turn it into a mixed?
You know, honestly, if you wrote this or this in a test, it would be absolutely fine. Okay?
Wait.
Yep.
As it is clear like y1 over y2 and then x over x
It is, okay, so we're going to generalize this now, okay? So we did this with numbers. If I had to replace these all with letters, so let's call this x1, actually let's call it x2, and, oops. So let's imagine that this point is actually x2, y2, and this point is x1, y1. We can come up with the general formula for the equation of the gradient, or the formula. So gradient is going to be some of the, what's going to be the top line?
y1 minus y2 minus y1.
Okay, y2 minus y1 divided by?
x2 minus x1.
Good, x2 minus x1. Here's a question for you. Does it matter if I do y1 minus y2 over x1 take away
No.
x2?
Because then they'll both be negative, so I cancel out.
Right, excellent. Okay, it doesn't matter which way around you actually do this.
Wait, what do you mean?
You know, if I do 2 take away 9 divided by 1 take away 7, you'll get exactly the same answer, okay? Yeah, because the negatives won't cancel in the division. So this is a really important formula, okay? That enables us to work out the gradient. When you come to do questions with this, we're going to do some now in a second to practice. You'll be given your 2 sets of points. So let's imagine we have to work out the gradient between 0.34 and 710. The way that I always go about this, and I recommend you always label them. So let's say this is x1, y1, x2, y2, and then it's a case of putting it into your formula. Okay. Did you do this again? Did you do this last year?
Yeah.
Yeah.
Okay, good. All right.